Before we proceed to our discussion, let me first introduce to you our group members named Abaya Angelito, Alfonso Dave, Balbero Darin Hill, Bautista Bernadette, Magno Kimberly, and Johnson Precious IB, and we are the Electrica Shocking Group from BSEE 3A. We are here to discuss wind farm. First, what is wind turbine? A wind turbine is a type of renewable energy that harness the power of wind to produce electricity. So, isa siyang uri ng teknolohiya na ginawa upang makakuha ng enerhiya or energy mula sa hangin. A wind turbine is a mechanism that spins in a moving fluid like gas or liquid and harvests part of the energy that passes through. It generates electricity using wind power. So, nature has always included renewable energy resources or sources like wind turbine to power and sustain life on Earth. Wind turbines come in a variety of sizes and application. From huge ones used by utilities to power a grid or ginagamit yung malalaki para sa mga utilities or yung tinatawag natin na wind farm. And then, yung maliliit naman na wind turbine is para sa mga residente na malapit doon sa location ng wind turbine na kailangan or required ng electricity. Wind turbines have an average lifespan of more than 25 years. The rapid growth of wind technology has increased the durability of wind turbines. And then, let's now discuss the parts and individual function of wind turbine. The basic idea is that wind turbines uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blade which spins a shaft that is connected to a generator which result in generation of electricity. So, the large number of wind turbines usually called wind farm. And then, let's now discuss the parts and individual function of wind turbine. So first, we have blades. The blade is the part that spins in response to the wind's power. It connects to the low-speed shaft via the hub. So, the low-speed shaft is attached to the gearbox. The blades is placed at the hub which interconnected to the vital inside the nozzle. Siya yung mahabang parts ng wind turbine na umiikot para makakuha ng power that capture the kinetic energy of the wind and convert it into electrical energy habang nagro-rotate. The blades are typically made of composite materials such as carbon fiber, fiberglass, or a combination of both. The wind turbine consists 3 blades. So why do wind turbines have 3 blades as opposed to fewer or more? Bakit nga ba kadalasan na 3 blades yung ginagamit na design sa wind turbines? The majority of wind turbines typically run with 3 blades as standards. In actuality, the choice to create turbines with 3 blades was a compromise, though in recent years, 3-bladed turbines have become the industry norm for producing renewable energy. This does not mean that this will be always the case. Better, more effective design are still being worked on by engineers for next energy producing projects. So, ang 3 blades nga daw is ideal siya na ginagamit para sa wind turbine. Pero kung tutuusin, nagwo-work pa yung or nag-iisip pa yung mga engineers kung mas okay nga ba yung mas marami or mas mag-i-stick sila sa 3-bladed na wind turbines. Next is blade design. Wind turbine blades must often be large and tall in order to generate a significant quantity of power. Sabi nga, the longer the better. Blade design involves aerodynamic profiles, length, twist, and taper to maximize energy, capture, and structural integrity. So, mas makaka-capture siya ng kinetic energy na galing sa hangin kung mas malaki o mas mahaba yung blade design na gagamitin. Improvements in design have resulted in new wind turbines that are more compact, quieter, and produce more power with less wind. So, as you may see in the picture, this wind turbine length vary at around 50-meter average with 100-meter currently the longest wind turbine from Siemens Gamesa. So, doon nyo siya matatagpuan.
Wind turbine, parts and design. Blade design. Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are crucial to the blade design. Ang mga airfoils ay ang cross-sectional na hugis ng mga blades na tumutukoy sa aerodynamics nito. Ang mga ito ay mahalaga sa disenyo ng talim. Wind turbine parts and design. With the help of airfoil design, a wind turbine may move its blade tips faster than the wind, producing more power and higher efficiency. Sa tulong ng disenyong ito ng airfoil, maaaring ilipat ng wind turbine ang mga dulo ng blade nito ng mas mabilis kaysa sa hangin na gumagawa ng higit na lakas at mas mataas na kahusayan. Wind turbine parts and design. Blade, aerodynamic lift, and drag are the two aerodynamic forces produced by wind turbine blades. Wind and the airfoils are to blame for this. Ang lift at drag ay ang dalawang aerodynamic forces na ginawa ng wind turbine blades. Ang hangin at ang kanilang airfoil ang may kasalanan dito. Lift force is a perpendicular to air flow and align the blade rotation. Lift force ay patayo sa daloy ng hangin at nakahanay sa pag-ikot ng talim. Drag force is in the line with apparent wind direction which is in opposition of the blade motion. Drag force na ayon sa maliwanag na direksyon ng hangin na sumasalungat sa galaw ng talim. A wind turbine consists of five major parts and many minor parts. The main components are the foundation, the tower, the rotor, and hub, including 3 blades, the nacelle, and the generator. The installation of all these elements required a specific wind turbine equipment to fulfill the needs of each one. Ang wind turbine ay binubuo ng 5 pangunahing bahagi at ang maraming minor na bahagi. Ang mga pangunahing bahagi ay ang pundasyon, ang tore at ang rotor at ang hub, kabilang ang 3 blades, ang nacelle at ang generator. Ang pag-install ng lahat ng mga elementong ito ay nangangailangan ng tiyak ng wind turbine equipment upang matugunan ang mga pangangailangan ng bawat isa. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. Ang isa pang bagay na maaring dalhin ng airfoil ay para sa talim upang makamit ang pagkakaiba ng presyon sa magkabilang panig. Wind turbine, blade aerodynamics. The reason for blade rotation is actually that high pressure air pushes on the less curved side, or the side with slightly concave part, while the most curved side or the convex side generates low air pressure. Ang dahilan ng pag-ikot ng talim ay talagang ang mataas na presyon ng hangin ay tumutulak sa mas kaunting kurbadong bahagi o sa gilid na may bahagyang maluklong bahagi, habang ang pinakurbadang bahagi o mas malalim na bahagi ay bumubuo ng mababang presyon ng hangin. Wind turbine aerodynamics, blade wind orientation. This is the question. Now, based on the figure illustrating the optimum angle of attack, what are the leading and trailing edges of the blade made of, both in front and back? Ang mga propeller ay karaniwang binubuo ng dalawang bahagi, ang mga blades at ang hub. At ang parehong bahagi ito ay ang sariling subset ng mga bahagi. Ang propeller ay karaniwang alinman sa fixed pitch o controllable pitch, at ang parehong mga system ay karaniwang nagbabahagi ng parehong mga bahagi. Bagamat gumagana ang mga ito sa iba't ibang paraan, susuriin natin ang mga pagkaibang ito sa pamamagitan ng higit na detalye tungkol sa iba't ibang bahagi ng propeller ng binubuo. Airfoil design. Airfoils, the cross-sectional shape of wind turbine blades, are the foundation of turbine blade design, generating lift and drag when they move throughout the airfoil play a key role in improving the aerodynamic performance and structural durability of turbine blades. Ang mga airfoil, ang cross-sectional na hugis ng wind turbine blades, ay ang pundasyon ng mga disenyo ng turbine blade. Bumubuo ng pag-angat at pag-drag sila na simpapawid. Ang mga airfoil ay gumaganap ng isang mahalagang papel sa pagpapabuti ng pagganap ng aerodynamics at tibay ng istruktura ng mga blades ng turbine. Wind turbine aerodynamics, blade rotation. The question is, what will be the rotation of the blades? The rotational kinetic energy, KE, rot for an object with a moment of inertia, I angular velocity, sigma, is given by helicopters store large amount of rotational kinetic energy in their blades. Work and energy is rotational motion are completely analogs to work and energy in translational motion. Thus it pushes in the direction of the side with the greater curvature or the side of the less curved. Just like an airplane wing, wind turbine blades work by generating lift due to their curved shape. That side that most curve generates low air pressure, while high pressure air beneath pushes on the other side of the table-shaped aerofoil.
Blade design. Its aerodynamics were further improved by twisted and tapered blades in addition to its curved design. The blade's ability to twist and taper throughout its length enhances the angle of attack, resulting in increased speed, efficiency, and lift. The longer the better blade design, longer it gets, the more capable it gets in capturing kinetic energy coming to the wind. To produce an amount of power, wind turbines generally need to be large and tall. It is shaped to generate maximum power from the wind of minimum cost. Its lengths vary around 50 meters with 123 meters concurrently the longest. Airfoils is the cross-sectional shape of the blade that determines its aerodynamics. They are key to blade design. The airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies. This is the question. Taking into account every aspect associated with the design and functioning of the wind turbine, how many blades is the optimal design based on the earlier slides? The back of a wind turbine blade is more curved than the front, as we already know. This varying shape causes a pressure difference as air passes over the blade, which rotates the blade. The air moves behind the wind turbine blade more quickly than in front of it because the blade is blocked. The blades revolve as a result. To guarantee the best efficiency, engineers must take drag and speed into account while constructing blades. Wind turbine. Number of blades. Rule of thumb in wind turbines. A common rule of thumb in wind turbines is the 3-2-1 principle, emphasizing the prevalent use of 3 blades for a balance between efficiency and stability. 2 blades for simplicity and cost-effectiveness in low wind speed conditions, and specialized application utilizing 4 or more blades for enhanced ability and durability. Additionally, ongoing technological advances may introduce variable blade number designs, adapting to changing wind conditions for optimized energy capture. The fewer blades used, the more efficient and less drag there will be. The number of blades increases torque and decreases the optimal rotation speed. Drag decreases with fewer blades. 1 blade. A 1-blade wind turbine has a single rotor blade, differing from the common multi-blade design. Despite this, experimental 1-blade prototypes aim to simplify structures, potentially reducing cost. Designing a reliable 1-blade turbine possesses challenges due to balancing issues and asymmetrical forces. 2 blades. Less common than 3 blades design are lighter, potentially more cost-effective, and claim reduced noise. Maintenance is simpler, but stability challenges and potential efficiency issues exist. Defined use in distributed energy projects and ongoing advancement aim to address associated challenges. Also, the wind turbine struggles to swing. A 2-blade turbine still produces a vertical to horizontal oscillation in the blades due to an effect known as gyroscopic precession. This generates additional stress on the mountain bearings and accelerates their deterioration. Three-blade wind turbines are the standard in large-scale wind energy projects, balancing stability and efficiency. They offer optimal aerodynamics design, reducing noise and vibration while providing a visually appealing and cost-effective solution. Well established and widely used, the symmetrical arrangement ensures smooth startup and shutdown procedures. More than 3 blades. Wind turbines with more than 3 blades are less common but can offer advantages such as increased stability and potentially lower noise levels. They may have lower cut-in speeds, making them suitable for areas with variable or lower wind speeds. However, the added complexity and cost, as well as potential reduction in aerodynamics efficiency are considerations. Blade tilting mechanism. The relative wind speed angle varies with wind speed as well. The blade tilting mechanism in wind turbines is essentially for optimizing efficiency and adapting to changing wind conditions. Typically achieved through pitch control, these mechanisms allows individual blade adjustments, enabling dynamic responses to varying wind speeds and optimal energy capture. It plays a vital role in overspeed protection by reducing aerodynamic loads during high winds and prevents structural damage. Blade tilting utilizes both active and passive systems, often employing hydraulic or electric actuators for precise control. Beyond enhancing turbine performance, this mechanism contributes to blade stability by facilitating smooth transitions between different operating conditions. Ongoing technological advances continue to refine blade tilting systems. Contributions to the overall reliability and effectiveness of wind energy generation.
Nacelle. The housing at the back of the blade which contains the slow-speed shaft, gearbox, generator, and other small parts inside it, which means that nacelle is a streamlined enclosure on an aircraft or wind turbine that houses important components like engines or generators. It helps reduce drag and improves aerodynamics. And the nacelle sits atop the tower and contains the gearbox, low and high speed shafts, generator, and brake. Some nacelles are larger than a house, and for 1.5 MW or megawatts geared turbine can weigh more than 4.5 tons. Gearbox. The components which converts the slow rotation of the blade into faster speed. This is needed simply because the rotation of the blade generates from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 1,500 RPM for 50 Hz and 1,800 RPM for 60 Hz. In no way it is feasible for a turbine blade to move that fast. It is often called a transmission, which means that gearboxes simply refer to a set of gears and their casing most commonly found in automobiles. Since most motor vehicles engines have high operating and idling speeds, transmissions allow the machinery to operate efficiently and even aid in slowing and shutting down machinery. A gearbox is typically used in a wind turbine to increase rotational speed from a low speed rotor to a higher speed electrical generator. Gearboxes in wind power transmissions, low speed, high torque wind turbine rotation to higher speed required by the generator, which converts the mechanical power to electricity. Gearbox running gearbox running conditions are challenging and lifetime expectations are high. Wind power energy production struggle with high costs. Um, Another thing is a common ratio of a gearbox is 91 with a rate of 16.7 RPM input from the rotor to 1,500 RPM output for the generator. Next, direct drive or gearless. There is no gearbox, and the main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of PMDD generator or permanent magnet direct drive. Generator reduces fatigue and stress on the turbine, resulting to reduced noise and vibration, longer lifetime, and lower cost of maintenance. And next, the main disadvantage of PMDD is that to make up for its lower rotation, more magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than a gear-type wind turbine. Another thing is that the additional magnets being used in this type is made out of neodymium, which is expensive. And the cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbine until recently. But other experts claim that direct drive technology will eventually become the dominant one, since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generates have more possibilities for improvement. Which means that instead, the rotor shaft is attached directly to the generator, which is spin at the same speed as the blades. They work by connecting the rotor directly to the generator to generate electricity. And the next one is brake. The brake system in a wind turbine is a protective device coupled with sensors, which automatically stops the rotation of the blades whenever it detects activities that could harm the system during operation. Or very high wind speed, vital parts not working, maintenance in power lines, and etc. Those are the examples of the brake. Um, and which means the turbine brakes are not like brakes in a car. A turbine brake keeps the rotor from turning after it's been shut down by the pitch system. Once the turbine blades are stopped by the controller, the brake keeps the turbine blades from moving, which is necessary for maintenance. And the last one is yaw system. is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nozzle on top of the tower so that the sets of blades is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. Ensures that the wind turbine is producing the maximum amount of electrical energy, which means that the yaw drive is an important component of the horizontal axis wind turbines yaw system. To ensure the wind turbine is producing the maximal amount of electric energy at all time, and the yaw system can adjust wind turbines and make their swept surface vertical to the wind direction, capture wind energy fully and reduce energy lost.
Wind turbine parts and function. Una ay tower. In the context of wind turbines, the tower is the structure that supports the turbine components, including the nacelle and blades. Ang mga bagong pagunlad sa teknolohiya ng tower ay ng wind turbine ay nagbubukas sa mas malalim na ugnayan sa pagitan ng pagbababuti ng enerhiya at pagiging eco-friendly. Ang paggamit ng modular na torre ay maaaring i-assemble on-site na nagbibigay daan para sa mas mabilis na cost-efficient na pagtatayo. Gayun din ang mga torre na mayroong aesthetic consideration tulad ng mga nababalot ng landscape-friendly designs ay nagbibigay daan para sa mas malawak na social acceptance ng wind energy projects. Ang mga torre na may built-in energy system storage ay nag-aambag ng pagpapatupad ng grid flexibility na nagbibigay daan sa mas efficient na paggamit ng enerhiya mula sa wind turbine. Sa kabuuan, ang mga pagbabago sa teknolohiya ng wind turbines ay nagbibigay inspirasyon sa pagtahak ng landas ng renewable energy tungo sa sustainable and integrated na sistema. Okay, next. Okay. Wind turbine, tower blade diameter ratio. The tower and blade diameter ratio is consideration in the wind turbine design, ensuring optimal performance in the matching tower height and length of the turbine blades. Okay, ang hinahanap na ratio ng taas ng tower at diameter ng blades ay dumidepende kung saan mas malakas ang ihip ng hangin. Sa paggamit ng advanced na models and algorithms na sa computational fluid dynamics ay nagbibigay ng mas mataas na antas ng presisyon sa pagsusuri ng aerodynamics ng mga blades. Ang adaptive control system ay tumutulong sa mga blades na mag-adjust sa real-time na pagbabago ng hangin na nagbubukas ng mas mataas na potensyal para sa pag-convert ng enerhiya. Ang mga tower ay may built-in sensors para sa real-time monitoring ng kondisyon ng blade ay nag-ambag sa mas mabilis na pagsusuri ng wear and tear na nagbibigay daan para sa mas epektibong preventive maintenance. Ang pagsasama-sama ng blockchain technology sa monitoring system ay nagbibigay ng mas mataas na seguridad at traceability sa pagpapahintulot ng transparent na sistema para sa buong life cycle ng wind turbines. Okay, next. Okay. Wind turbine. Ideal location. Ideal location for a wind turbine are the areas that consistent with strong wind patterns factors such as wind speed, direction, and the turbulence and are the crucial determining the optimal site for efficient energy generation. Ang hinahanap na pagpili ng tamang lokasyon para sa wind turbine ay naglalarawan ng isang mas detalyadong proactive na pagsusuri sa kalikasan at kultura. Ang mga advanced environmental impact assessment tool ay may kasama ecological models and habitat sustainability analysis na nagbibigay ng mas malalim na pagsusuri sa epekto ng wind farms sa biodiversity. Ang paggamit ng advanced geospatial technologies tulad ng LiDAR or light detection and ranging at satellite imaging ay nagbibigay ng mas mataas sa antas ng presisyon sa pagtukoy ng tamang lokasyon para sa wind energy projects. Ang mga adaptive community engagement strategies tulad ng paggamit ng virtual reality para sa visualization of the wind farms impacts na nagbibigay daan para sa mas mabisang komunikasyon sa komunidad. Ang mga teknolohiyang ito ay nagbubukas pa ng landas para sa mga holistic na pagsusuri at mas maayos sa pagtanggap ng mga wind energy projects. Okay, next. Wind turbine parts and function. Wind turbine consists of key components like nacelle, blades, tower, generator, and generator. The blades capture wind and the nacelle houses the generator and the tower supports the entire structure. Ang hinahanap na teknolohiya sa mga bahagi function ng wind turbine ay nagdudulot ng mas advanced at optimized na sistema. Ang pagsusuri ng paggamit ng smart materials tulad ng self-healing composites para sa mga blade na nagbibigay daan para sa mas matagalang buhay ng mga kagamitan. Ang pag-integrate ng machine learning algorithms sa monitoring system ay nagbibigay ng mas mabilis na predictive analytic para sa preventive maintenance. Ang mga advanced na design ng generator at gearbox tulad ng direct drive system ay nagbibigay ng mga mataas na efficiency at mas mababang maintenance requirements. Ang mga pagsusuri sa buong life cycle ng wind turbines mula sa pagtatayo hanggang decommissioning ay nagbubukas ng mas maingat na pangangasiwa sa mga buong proseso. Okay, next. Okay. Advantages of wind turbine. Wind turbine energy has several advantages, including clean and renewable energy sources, reducing greenhouse gases emission and contributing to energy independence. Ang hinaharap ng wind turbine ay nakatutulong sa pagiging pangunahing pagkukunan ng kuryente sa mas maraming bahagi ng mundo. Ang pagtataguyod ng renewable energy ay nagbubukas ng oportunidad para sa malawakang employment, industrial development at research advancement. Ang pag-unlad ng wind energy ay nag-aambag sa global layunin na babawasan ng carbon emissions na nagbibigay daan para sa mas malinis at sustainable na hinaharap. Ang pagpapalaganap ng wind farm ay nagtataguyod ng energy security. Ito ay nagbibigay daan para sa independent na pagkukunan ng energy. Para sa mga bansa at ang mga benepisyo nito ay nagdudulot hindi lamang ng mas malalalim na societal economic impact, kundi nagbibigay din ng inspirasyon para sa mas malawakang adopsyon ng clean energy. So, sunod natin ay disadvantages. Disadvantages of wind turbine. Challenges of wind turbine includes the intermittency dependence on wind turbine condition, visual and noise, impact and kind of need for suitable geographic location. Bagamat may mga hamon na hinaharap ang wind energy sa pagpapatuloy ng paglalakbay patungo sa mas sustainable at cost-efficient na pag-unlad, ang mga visual impact at noise concerns ng wind turbine ay masusing ina-address sa pamamagitan ng pagsusuri ng local regulations and advancement design. Ang financial challenges ay lalo na ang mas mataas na initial investment. ay pinag-usapan sa pamamagitan ng public and private partnership na paghahanap ng mas mabisang funding mechanisms. Ang social acceptance ng wind energy ay tinutok sa mas maingat na makikipag-ugnayan sa komunidad na nagbibigay ng boses sa mga lokal at na stakeholders. Sa kabila ng hamon na hinaharap na nagtataglay ng malawakang posibilidad para sa wind energy na matagumpay bilang pangunahing bahagi ng global transition tungo sa sustainable na source of energy.
So why nadako tayo from the largest wind farm? First of all, is yung Ganso Wind Farm. Ito yung pinaka-largest sa lahat ng nandito. Which capacity niya is 20,000 pero ang kaya niya lang ipundar ng enerhiya ay 7,965. Ongoing pa rin din kasi siya. So itong Ganso Wind Farm nakapaloob siya from China. Second, yung Alta Wind Energy Center which produce 1,548 megawatt pero yung ongoing din siya katulad ng Ganso Wind Farm. Ang goal niya is magkaroon ng 3,000 megawatt o magkaroon ng capacity ng 3,000 megawatt. Ito naman ay nakapaloob sa California, USA. Third, Bupandal Wind Farm. Ito naman yung wind farm na Yarina and it can produce 1,500 megawatts. Ito yung nakapaloob sa India. Next, Hornsea Project 1. Itong Hornsea Project 1, ito naman yung may capacity na i-produce ng 1,218 from United Kingdom or UK. And fourth, a fifth, Mark Bikegen Wind Farm which is ongoing din. If ika na pag nangyari ito, we can say siya yung pinakamalaki sa pangalawa or kasunod sa Ganso Wind Farm. Pero ngayon, ang kaya niya lang i-produce si 1,120 megawatts. Pero yung capacity na goal niya is 4,000. Ito naman ay starting from Sweden or yung country niya is Sweden. So lastly is the Silver Wind Park which have 1,064 and country niya ay India din. So, top 2, pasok yung dalawa sa India. So, mostly, pinaka-largest is yung Ganso Wind Farm. So, next, punta tayo sa Ganso Wind Farm. Ito yung the largest wind farm na ginawa or ongoing na ginagawa pa rin. So, Ganso Wind Farm. The Ganso Wind Farm Project or Jingguan Wind Power Base is a group of large wind farm under the construction of Western Gansu Province in China. In 2008, construction began on a 750 kV AC power line to carry electricity from the wind farm, and the construction of the wind farm themselves started in August 2009. In November 2010 official announced the completion of the project first phase involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,116 megawatts. Yes, it has an estimated cost of 120 billion Chinese yuan or $17.5 billion. The project is being built by more than 20 developers. So, katulad niya nun, ongoing pa rin siya. So, before, ito nung date na to 2010, over 3,500 turbines with an installed capacity of 5,000 megawatts. Doon yung nagawa na doon, no 2010 siya. At may estimated value na siya ng 120 billion Chinese yuan. So, next, the Burgos Wind Farm. The Burgos Wind Farm, the 150 megawatt Burgos Wind Farm is the largest wind power project in the Southeast Asia, located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind farm was $15 million, which was completed in 2015, located within 600 hectare site. The facility consists of 50 turbines, each with a capacity of 3 megawatts, generating electricity to the Luzon grid Each wind turbine rests on a tubular steel power, has a 75 meters hub height and 90-meter diameter. So ito yung wind farm natin or largest sa buong Pilipinas at sa buong Southeast East Asia. So yung Pilipinas ay may 50 wind turbines na Burgos Wind Turbines nagsasakop sa 600 hectare site na kaya mag-generate ng 3 megawatts which sa total of 150 megawatts na nagpo-produce sa buong Luzon grid. So yun lang. Next, wind turbine grid operation. So ito makikita natin kung paano gumagana yung wind turbine. So first, yung wind pupunta sa rotor blade para umikot, pupuntang gearbox na magpapadagdag ng bilis, tapos magde-generate siya ng electricity from nozzle to power cable mapupunta sa tower at mapupunta sa transformer at diretso na sa grid line or sa switchyard para mag-produce ng energy. So, yun lamang po ang aming report at maraming salamat.